morning. Today I have been invited by IAC Acoustics. Yeah! So now I'm gonna drive a little bit outside London and see what they're up to. How you doing, my man?
Not too bad.
Good to see you. Oh yeah.
Are you suffering from persistent cough?
Nope.
Sore throat? Any aches or pains? Any loss of taste or smell? Obviously we're in social bubbles at the moment. We have certain days that certain people are allowed in the office. Another group of people will be in tomorrow. If ever there's anything that happens as far as COVID is concerned, then the company can still keep on working.
Hi, nice to meet you.
Do we do that?
Yeah. My eye ended up on this thing. What is this?
This is a product that we took to a show up in London. It's supposed to replicate a jet engine, and what we did was we had a little power control. It's not plugged in at the moment, but we plugged it in so that the air would come through here, and we had streamers on this. You can see there, and it shows you that it deflects the air. So
Right.
these are airport protection barriers, and you can see the shape of it all here.
Airport protection barriers.
Yeah. An aircraft parked at the terminal, and it wants to back up, and then it starts up, and the jet wash, it might hit the terminal, or it might hit the road, or it might hit traffic. These things deflect the air upwards.
Right.
So you can see the special shape. So it hits it, and it turns it up at 60 degrees.
And at the same time it reduces the sound of it.
A little bit, but that's not really the point. The point is very much to deal with the jet blast.
I see.
These things deal with the acoustics. So there you've got the biggest aircraft in the world, the A380, and this is the biggest ground run-up pen in the world. So this reduces the noise.
Wow.
There's a demo. That's one of the guys at one of our sites. There was an aircraft the other side of that running, and so the jet wash was coming through here and it was going up and lifting his jacket.
Wow.
So it shows that he's protected, but the airflow is going upwards. Different types of these. That one's an angled one. That one's a fully solid one for bigger protection. And that one's a vertical one. And this is a vane one.
So it turns out you guys do a lot more than just recording studios.
We do a lot more than recording studios, yeah.
First of all, welcome to IAC Acoustics. My name is Mike Campbell. I'm the Managing Director of this fine establishment. My background is manufacturing. I was the operations manager for companies before I came to IAC Acoustics. IAC Acoustics needed a role where a new guy was going to come in and refresh the operations and manufacturing facility and bring them into the 21st century. So I took on this job back in 2003. Started working on the Winchester factory as it was then, modernised it, put lean manufacturing in there, drove the efficiencies, improved the costs, made us more competitive in the market space. And then we decided that, our shareholders decided that we needed to expand and develop that same process within our sister companies. So they gave me a group role, I became the group operations director, and I remained in that position for 10 years. After 10 years, our shareholders decided to sell the company, so I moved on. But after a few years, 3-4 years, I got invited back again to be the Managing Director of IAC Acoustics. So I've come back in again, and we're now on a path to an even greater future. So IAC Acoustic is in industry to provide noise suppression systems to people for a wide variety of different markets. If you can think of the most extreme situations where a lot of noise is generated. Aviation jet engines, gas turbines, very noisy pieces of kit, fans, compressors. These are the types of pieces of equipment that if you were to stand next to them, they would permanently damage your hearing. We can provide enclosures around these things that suppress the sound, that absorb all of the sound from these pieces of equipment and protect personnel and the public. To make things more interesting than that, these pieces of equipment quite often need airflow. They need to be able to control the temperature. So we need to be able to allow air to come into the enclosure and for air to escape from the enclosure. So we have to provide attenuation. These are systems where there is natural air flows into a space, but at the same time it stops the noise from coming out. You can have something that could damage your hearing half a metre away from you, and yet we are able to ensure that airflows get into this piece of equipment for the optimal performance of the equipment. If you look at a slightly different extreme in the recording industry, in schools, in classrooms, in music practice rooms, you need to create an environment which protects the outside space from the instrument or from the music that's being played or from the children in the classroom, but at the same time gives a certain amount of absorption, but at the same time the right amount of reverberation to give the people in that environment the right kind of feeling, so they are able to respond to their music and react in the right way. And if you go to the furthest extreme, the quietest spaces on earth, we can produce anechoic chambers. We can produce audiology rooms where you can have your hearing tested. Any sound in that kind of environment is a problem, so we have to have absolute absorption, no reflection at all. Our anechoic chambers are the quietest spaces on earth. Okay, so we've got a suite of products, panel systems, louvers, attenuators, doors, windows. We are able to create a very comfortable environment where people can work in or people can play in, but it stops that noise from breaking outside of that particular environment. It's designed to be very tactile, it's designed to be an architectural feature, it's designed to be nice to look at, to be modern. And the suite of products we have work in a modular way so that we can provide a facility that is designed specifically to the customer, that meets their specific needs. To make things even better than that, because it's modular, if the customer then comes to us at a later date, we are able to reconfigure at quite a low cost. It's still using the same materials, so we can actually move things, we can reconfigure them, we can accommodate for growth or contraction if necessary. And if you look at the suite of products we've got, they complement each other very nicely. So the acoustic doors work very well with the panel systems work very well with the windows, the attenuation, make sure that you get airflow in there and the temperature is perfect. It works very well as a suite of components. So IAC has been famous for its doors. If you think about acoustic applications, doors quite often are the weak spot. You can make a concrete wall, you can make a very solid structure, but the door where you have to open and close it tends to be the weak spot acoustically. IAC Acoustics have always had the best quality of acoustic doors, the highest performing acoustic doors. With modern times, standards have moved on. CE standards have come in, new fire standards have been generated, and with the recent events with Grenfell, the new fire authorities are concerned about historic records, so they always want you to retest. As we were going through a retest cycle, we decided we wanted to modernise our door. We decided we wanted to make it the most architectural, prettiest door that you could possibly have, a door that would look right in any setting. So we've gone to a lot of trouble to redesign our door that looks good aesthetically, that works acoustically very well, that's got very clean lines, that is very easy to operate, that has a flat threshold for DDA compliance so that wheelchairs and people with disabilities can walk through without any risk, and that will last a long time. We spent a lot of time developing this door. We're very excited about the new door that we've produced. We think it's going to be received by the market very well. My favourite band? Green Day. Is that a good one? I've been to see them. I went to see them in Hyde Park 2 years ago. They were fantastic. But I've got a lot of favourite bands. Before that it was probably Queen. But what's your favourite band?
Pink Floyd.
Pink Floyd. I went to see them as well. I'm that age. So we're currently doing some doors for Dave Gilmour, Noel Gallagher, and Peter Gabriel. We've done some doors for Peter Gabriel in the past. We've done a lot of famous doors. We've done a lot of doors and studio work in Abbey Road, for example. So we're quite well known within the studio market. So this is Dennis. Dennis works for our design team. Dennis has your particular door on the screen, at least one of your doors. So this is of the new design. It's got hidden hinges, it's got very smooth lines, it works to 50 dB acoustically, and it's got a fire rating, 1.5 hour fire rating.
I know because I was there.
Absolutely, yes. It's exciting, isn't it?
Amazing. Look at this program, this is awesome.
So our doors are developed in a 2D package. We've got a suite of software that is able to develop and design the doors very quickly. When things get more complicated, we tend to do it in 3D, and we can show you an example of 3D in a minute if you like.
Is this the famous anechoic chamber you were talking about?
Yeah, this is a chamber we're currently doing for Ford.
So we're supplying all the floor support rails for a floor that the vehicle can then drive onto. The air comes through this here, it also comes through the two sides, and then you'll see a slot on this side. A motorised drive shaft comes through here, called a dyno, and runs the chassis, and they measure the noise that comes off the chassis. It's all about developing vehicles, and in this instance we're doing a complete turnkey supply of internal acoustics, the crane, the ventilation system. As you can imagine, in a quiet cell like this where you don't want any reflections off the walls, the airflow has to be very quiet as well, but also quite a lot of airflow. So we're shifting a lot of air very quietly in a cell that basically absorbs all noise down to, I think it's 60 hertz.
60 hertz?
Yeah.
Wow.
No reflections.
Thank you so much, man.
All right.
Is it true that now we're gonna watch my actual doors being built?
We are. We're going to take you to the factory and you're going to see the doors being built.
Awesome.
They're very red.
They are, right? Shocking.
This is the start of the manufacturing process. In front of us here is what's called the CS line. It stands for compact storage. It's a storage facility for the raw material. It can hold up to 720 tons of material. And what happens here is that the program is sent from the office directly to the lasers. The lasers send the commands to the storage line. The storage line feeds the material directly onto the lasers. Laser then cuts the material. Once it's been processed, it takes it away and puts it back onto the storage line. So this is some material that's been cut. This is actually waste material. This is what's called the skeleton after it's been cut. There's some products down here which are finished materials that have been cut and folded. Might be worthwhile actually having a look at the punch laser in operation. Through this window here you can see the material being punched. At the moment it's punching an awful lot of holes. Once the holes are being cut, to actually cut around the profile of the plate, it will switch to laser mode and it will cut it using lights. There's a high intensity laser beam which will cut through the material. Gives a very accurate finish. And this is the scrap that goes into the bin.
Wow. That's incredible, isn't it?
It's an amazing machine.
Can I take it home?
Not this piece, we've got some more things that you can take home. This is the folding area. What you have is a range of Armada brake presses, and over in the corner here is ATC line, which is the automatic tool changer line. So this is a very unique machine. When you're folding parts, you need to change the tools on a very regular basis. The advantage of this machine is that it changes those tools automatically for you. It doesn't need any labour to be able to change it. It's very quick, very efficient. Okay, so I'm now going to introduce you to Richard. Richard has worked for IAC for about 300 years, I reckon. He's made many thousands of doors in his time, and then he moved into project management. He must have installed hundreds of thousands of acoustic doors. So when we came to design our new door, we invited Richard to join the design team. All the way through this process, Richard has made the first prototypes. He's been with us when we tested the doors, acoustically and in the fire tests, and now he's helped Dr. Mix with their new doors, assembling them, testing them, making sure they're all okay. What we've got here at the moment, Richard's going to introduce to you.
Hi.
Hi.
At the moment we're making here the window frames for Dr. Mix. And we have the window frames over here, which is part sub-assembly. They will go from here to the spray booth.
These are my window
That's
frames.
your window frame.
Wow.
And Carlos is making the front section for the windows. Yeah. So these will be all clamped down, welded up, that we tack together, make sure everything is square, and then everything will be welded up fully, cleaned off, and sent over to the paint booth. We have other sections for your door down here. You can tell this is Dr. Mix. He's only got Dr. Mix on the door here.
Woo!
Can we see the doors in manufacture?
The doors have all been done. They've all been done, yeah? We need to go down to the other section where the sub-assemblies will be put together, and we've got one set up and you can try your new door.
Lovely! Thank you so much!
No problem.
Wow, and where are we now? Ooh, Rockwool. That's a familiar sight.
This is where they fit up all their doors and all the other manufactured parts that have been painted and are ready to be put together. Over here, we have Dr. Mix's frames in the process of being made.
I love them. I love the color. Okay, you guys ready?
Red doors.
Red doors.
So red. So sweet. Oh man, look at those.
This section of the door is what we call the back pan. The back pan will have angles fitted to it, and it will be blipped over and put onto this section, which will be full of Rockwool and screwed in position. Here we have your frame in two separate pieces. This is the rear section of the frame. See all the fixing holes which are through here. This section will also be filled with plasterboard, and once that's filled with plasterboard, it'll be put on top of this section. And you can see what we're doing on this section. No big secrets, Rockwool and fiberglass.
No big secrets, just the
The
best.
biggest secret is that now we're going to come and see your door all hung up with the furniture on and looking brilliant.
And what's that? You are not telling me this is the actual finished door. Get out of town. Who's there? They look so awesome. Look at them. Blessed is the day that I met you guys.
This is the first time we've used these hinges. They're all concealed hinges. And we've got a drop-down boot there.
If you press the end, you'll see the boot come down to the bottom.
Uh-huh. That's where the sound insulation really happens then.
So as the door closes, that drop-down boot sits against the threshold, and it's an airtight seal that stops any sound from leaking. So you can play your music to your heart's content as loud as you want. You can turn up the bass, and it'll work perfectly. You won't disturb the neighbours.
That's music to my ears. It's time to install these babies in my studio.